Welcome to the 6A, 6B test review. So for the first problem, I'm going to graph this. And the second problem I'm actually going to do by substitution. So the first problem, graphing. Remember, we're in y equals mx plus b. The m is your slope. So you're looking at what number's in front of the x. Well, that's a 1. That's going to be my slope. And then the b is my beginning point. That's the y-intercept. So that's always where you're going to start. So the y-intercept is going to be at -3. My slope is up 1 to the right 1. Up 1, right 1, up 1, right 1, up 1, right 1. Instead of going up and right, you can also go down and left. And there's my first equation represented as a line. My second equation, I'm going to start with 3. First, I didn't start about it, but it's y equals, so, and this is the m, x plus b. So it's already in y equals mx plus b form, so when you do that, you can certainly quickly graph it with the y-intercept of 3, and then we're going to have a -1 over 2. So down 1, right 2. Down 1, right 2. And there's our solution, where that's going to intersect with both equations. And that is 4 to the right, x is 4, the y is 1. So 4, 1 is my solution. All right, number 2, with substitution. With substitution here we have y is going to equal -x minus 3. So that means in any other equation where I see y equals or y, I can replace that with -x minus 3. So I'm going to replace the y there with a -x minus 3. And then we still have the -5x plus 1. And then we're going to solve. So I got to get my x's together. Typically I'm going to move my x's to the left side. So -1x plus 5x is 4x. And then 1. And I'm going to move my constants, which are my like terms, they're my numbers, to the right. And divide by 4. We get x equals 1. Now that's my x value of my solution. Now I'm going to take one of the equations, so I'll just take the bottom one here, and I'm going to substitute in x equals 1 for the x. So y equals the -5x, so that's -5 times 1 plus 1. -5 times 1 is -5 plus 1 is -4. So my x value is 1, my y value is -4. X then y. There's my solution, 1, -4. You can certainly check it by graphing. Number 3, I'm going to graph these. Each one of these you could also do by substitution. I'm just going to do it by graphing, so you can always check it by substitution. You should get the exact same solution. So I'm going to subtract x, so it's -y equals a -x minus 3. -1 is in front of the y, that's attached to the y by multiplication, so I'm going to divide by -1. Anytime you multiply or divide in an equation, you have to multiply or divide every term, so it's -1 divided by -1 is +1. -3 divided by -1 is a +3. So let's graph this. We have a y-intercept of 3, and then our slope is up 1, right 1, up 1, right 1. Or you can go down and left, down and left, down and left, down and left, down and left. All right, second equation, bottom equation. Let's graph that. So I need to get y by itself. So again, the x is positive, so I'm going to subtract x. You can think of it as a +1 if you really want. And you get positive y equals a -x. That 1 is positive, so it's +1. Graph it. We have a +1 as your y-intercept, and then it's slope of -1 over 1. So I'm going to go down 1, right 1, down 1, right 1. Problem with this is I'm getting further away from the other line. So instead of down and right, I'm going to go up and left. Well, there we go. And we'd have our solution. And here's our line where they intersect. We got to label that point. That point is 1 to the left, so that's x equals negative 1, and the y is 2. So negative 1, 2 is our solution. Alright, next problem. Let's get the y by itself so we can get into y equals mx plus b form. I'm going to move the x term first. And the x term I'm going to put first because that's where my slope is going to be located. Then I'm going to divide by 2 to do the opposite of multiplication. Negative 3 over 2x minus 4. Negative 4 is my y-intercept. And then my slope is down 3, and right 2. I can't go down 3 and right 2. It's kind of off the graph, and that wouldn't make a very good graph. So instead of down and right, I can go up and left. Up and left. Now let's graph the second equation. Gotta move my x term. Divide by 2. We got our y-intercept of 1. Then we have our slope of down 3, right 2. Down 3, right 2. I can go up 3 and left 2. What's happening here? Well, this looks like those lines are parallel. Let's take a look back at our equations. Equation of negative 3 over 2, negative 3 over 2. Well, they do have the same slope, so they're parallel. Are they the exact same equation? Well, that has a y-intercept of negative 4 and that has a y-intercept of positive 1. So they're not the same equation. So ultimately, my solution is there is no solution. There's no place that they're going to intersect. So no solution is my answer. All right, take a look at the back. Number 5, I'm going to graph these. Top equation, I need to add 9. And then I need to divide by negative 3. Negative divided by negative is a positive 7/3. 9 divided by negative 3 is a negative 3. So my y-intercept is at negative 3, and I got to go up 7 and then right 3. That's my slope. And I can't do that again because it would be off the graph, so I only have 2 points, 2 coordinates. And the bottom equation, let's get that graphed. Alright, if you want to switch these around so our y is on our left side, it's not a bad idea. You don't have to, but then it's a little bit easier because it's a lot more like a problem that we've solved before. It looks a lot better. Divide by 3, divide by 3, divide by 3. Y equals 7/3 x minus 3. So negative 3 is your y-intercept. I'm going to go up 1, 2, 3, 4, 5, 6. Did I not go up 7 before? Biscuits and gravy. I didn't. My bad. So it should be right here. And then the next one should be here. Oh man, that's the same line. Oh my goodness, that was an awful drawing. So those are the exact same line. If you look at the equations, we could have told that. Same slope and same y-intercept. That would be infinite solutions. Alright, moving on to next problem. You need to solve for y. If you want to switch them around so your y is on the left side of the equation, you certainly can. Two y equals 3x plus 2. Divide by 2. And we got our y-intercept of 1. Go up 3, right 2. Or down 3, left 2. Down 3, left 2. There's my equation, or my line that represents that equation. The bottom equation, we have a negative x minus 6 equals negative 2. Going to switch them around, we certainly can, so the y is on the left side. You don't have to do this. And we're going to divide by negative 2, divide by negative 2, divide by negative 2. We have y equals a negative divided by negative is a positive. And then you have a 1/2, that's going to be your slope. That's in front of 1 is always in front of the x. And then negative 6 divided by negative 2 is positive 3. So our y-intercept is positive 3. And we have a slope of up 1, right 2. And there's our intersection already. And what's that coordinate? That coordinate is 2 to the right. So the x is going to be 2, and it's up at the y is 4. That's going to be 2 to the right, up 4. That's our solution. All right, bottom problems. We have y-intercept of 2, up 1, right 2, up 1, right 2. Also down 1, left 2, down 1, left 2. And then it's equal to, so it's going to be a solid line. And then it's less than would shade below the graph. So down below the line. Second equation, we have a y-intercept of negative 3. And then 3 over 1 is your slope. And then it is equal to, so it's a solid line, not dashed, solid line. And then it's greater than. And where they overlapped, that is your, and including the line because it's equal to, any coordinate in this area is a solution. So any coordinate in this area, including the line, because that's equal to the boundary of that shaded area, I should say, on the line, is a solution to both inequalities. I don't have the actual answers down below here, so you're going to have to figure that out, or ask me when you get to class before the test. Let's graph the second one. We have positive 1. We're going to go up 4, right 3, or down 4, left 3. It is not equal to, so that equal to is not there, so it's going to be a dashed line. So say that it's not equal to. And then it's greater than is shade above the line. Now in the second one, we have x is greater than negative 3. When the x-axis to negative 3, and x equals is always a vertical line. You could always think, where does x equal negative 3? Anywhere along this vertical line is where x equals negative 3. And if you don't believe me, pick a point along there, like this point right here. That's negative 3, 2. The x is always negative 3. This is negative 3, 4. X is always negative 3. At the origin there, or not the origin, at the x-axis, it's negative 3, 0. The x is always negative 3. So anywhere along that vertical line is where x equals negative 3. Now it's not equal to, so that's why I did a dashed line. And you might think, which way do I shade? Well, greater than, so what x, think about it, x is greater than, so what numbers are greater than negative 3? Well, like negative 2, negative 1, 0, 1, 2, 3, that's to the right. So that's shaded to the right of that line. That's greater than. Where are they overlapping? They're overlapping right in this top middle area. And this does not include any coordinate that's on the boundary line there, because those are not equal to. So anywhere in here, any coordinate in here is a solution. So not on the boundary line and not in the intersection, because they are not equal to. So just on the bound, not on the boundaries, just inside. All right, number 9. Let's graph this. So for this, I have to solve for y, get it in y equals mx plus b. So I can do 5x, subtract 5x. And 6 is positive, so that's why it's plus 6. And I'm going to divide by negative. Anytime you multiply or divide by a negative, don't forget to switch the inequality. So negative 5 divided by negative 2 is actually a negative divided by negative is a positive. And then that is a 6. That's a weird looking 6. 6 divided by negative 2 is negative 3. Let's graph this. Negative 3, up 5, right 2. And then dashed is not equal to. And now it's a less than the shade below. Next equation, we have x minus 2y is greater than negative 2. We're going to subtract x and divide by negative 2. Again, anytime you multiply or divide by a negative, we're dividing by a negative 2, we got to switch that inequality. Negative divided by negative is going to be a positive, so we can just make it positive. Negative divided by negative is a positive 1. In this case, 2 divided by 2 is 1. And if you want to know the fraction that you're going to use for slope, it's going to be 1/2. So we have 1 is your y-intercept, and then up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. And then it's, again, not equal to, so it's going to be a dashed line again. And then where are we shading? Less than. Less than's down below the line. And where are they overlapping? Looks like just in this area right here, not including the boundary, because that they are not equal to. Any coordinate in that area is the solution to the systems of inequalities. And last problem, let's work on it. We have 3x minus y is greater than or equal to negative 1. I'm going to subtract 3x. Negative y is greater than or equal to negative 3x minus 1. Divide by negative 1. The y, we divided by negative, so I got to switch to inequality. That's going to become positive 3. Negative 3 divided by 1. Negative 1 is positive 3. Negative 1 divided by negative 1 is a positive 1. So we have our y-intercept at 1 and our slope of 3 over 1. So I'm going to go up 3 from the y-intercept into the right 1. Or down 3 and left 1. Down 3, left 1. It is equal to, so it's going to be a solid line. Oh my goodness. A little hiccup there. And then less than is shade below the graph. And then our next equation, solve for y, so I'm going to subtract x, move the x, there are no like terms. We have a negative x minus 3. The y is a positive y, so that's why I just write y, which is like a positive there. And we have our y-intercept at negative 3. Our slope is negative 1 over 1. Or up, instead of down and left, you can go up and, or sorry, down and right, we can go up and left. Up and left, up and left, up and left, up and left. And equal to is a solid line. So we're going to draw a solid line. And then which way is above the equation? Greater than. Greater than is above. So the lines are going up. And then where do they overlap? Well, they overlap in this area here. And they are solid lines. So solid lines mean that it is part of the solution. So it's actually on the line also. Any coordinate on the line is also a solution. And it keeps going forever. But any coordinate in this area, including on the line and in the intersection, because they're both equal to, is the solution. I hope this helped you. Come